This is Math 6, Lesson 5-6, Equations with Fractions. We've solved equations with whole numbers and solved equations with decimals before. Now we're just going into fractions. The process stays the same. To solve an equation, you use inverse operations, which means if they add something to the variable, you will subtract it. If they subtract something from the variable, you will add it. You will undo what was done to the variable. Let's look at some examples. N plus 1/3 equals 11/12. Remember, the dividing line for a fraction, to separate one side from the other side, is along the equal sign. So if we look at this equation, n plus 1/3 equals 11/12. So I need to get rid of the 1/3. They added it to n. The inverse of adding is subtracting, so I will subtract 1/3 from n, and I will subtract 1/3 from 11/12, because whatever you do on one side of the equation, you have to do the exact same thing on the other side of the equation. 1/3 minus 1/3 cancels out, leaving me with n. 11/12 minus 1/3 needs to have a common denominator in order to subtract those. The common denominator between 3 and 12 is 12. So 11/12 can stay as 11/12. 1/3 needs to change to 12ths. 3 times 4 is 12, so 1 times 4 is 4. So I'm going to have 11/12 minus 4/12, and 11/12 minus 4/12 is 7/12. Now, it's always a good idea to check your equations, so I'm going to check my problem. To check this, I need to know if n plus 1/3 equals 11/12. I need to put in 7/12 for n. So I need to know, does 7/12 plus 1/3 equal 11/12? That's what I want to know. So I'm going to do this problem. I'm going to do it vertically because it's better than doing it horizontally. So I want to know what 7/12 plus 1/3 is. Common denominator between 3 and 12 is 12, so I can keep my 7/12. 3 times 4 is 12, 1 times 4 is 4, so this becomes 4/12. 7 plus 4 is 11. 11/12 does indeed equal 11/12, so this problem checks. Number 2. 2/5 plus a equals 13/20. Alright, to get a by itself, I need to undo what was done to a. They added 2/5 to a, so I need to subtract 2/5 from a. So I will subtract 2/5 here. I will subtract 2/5 here. 2/5 minus 2/5 is 0, so that leaves me with a. I need a common denominator between 13/20 and 2/5. My common denominator is 20, so I can leave 13/20 as 13/20. And 5 times 4 is 20. 4 times 2 is 8. So I'm going to do 13/20 minus 8/20, which is 5/20. But 5/20 is not in simplified form, so I need to reduce that. 5 goes into 5 one time. 5 goes into 20 4 times. So 5/20 reduces to 1/4. I can check this problem as well. I need to know if 2/5 plus 1/4 actually equals 13/20. That's what I'm trying to figure out. So let's look at this problem. So 2/5 plus 1/4. Common denominator here is 20. 5 times 4 is 20. 4 times 2 is 8. 4 times 5 is 20. 5 times 1 is 5. 8 plus 5 is 13, so 13/20 equals 13/20. This checks. Problem 3. X minus 1/8 equals 3/4. Here we subtracted 1/8 from x, so in order to solve this we need to add 1/8 to x. And if we need to add it to x, we need to add it to the opposite side as well. So negative 1/8 and positive 1/8 cancels out. So x equals 3/4 plus 1/8. We need a common denominator here, which would be 8. 4 times 2 is 8. 3 times 2 is 6. Plus 1/8 here. 6/8 plus 1/8 is 7/8. So x equals 7/8. We will check this one as well. So we need to know, does 7/8 minus 1/8 equal 3/4? That's what we want to know. Since we have a common denominator, I don't need to find one. 7 minus 1 is 6. 6/8, if you reduce it, is equal to 3/4. So 3/4 equals 3/4. This problem does check. Now, when you work with word problems, it can be a little confusing sometimes figuring out how to write the equation. Most mathematicians, most young people, can figure out whether they're supposed to add or subtract, but they can never figure out how to write the equation. The equation is the critical part. If you can write equations to simple problems, you will be much more effective in writing equations with more difficult problems. So we're going to work through this problem fairly slowly so you can understand how to write this equation. It says an empty container weighs 1/12 of a pound. The same container full of chopped fruit weighs 7/8 of a pound. How much does the fruit weigh? So I need to think about this. The first thing I need to remember is I have to define a variable. And my variable is defined by what the question is asking. It's asking me how much the fruit weighs. So I'm going to let x equal the weight of the fruit. Now, if I think about this, it says that an empty container weighs 1/12 of a pound. The same container full of fruit weighs 7/8 of a pound. So I know that the empty container plus the weight of the fruit has to equal the total weight. Okay? So the weight of the container plus the weight of the fruit has to equal my total weight. Okay? If you want to think of this as a picture, think of it as part plus part equals whole. The container part plus the fruit part equals the total part. Part plus part equals whole. So the weight of my container, we already defined that as being x, plus the weight of my fruit, weight of my container is not x. The weight of my container is 1/12. The weight of my fruit is x, because it says right here the weight of my empty container is 1/12 of a pound. The weight of my fruit is x, and the total weight is 7/8. So we have 1/12 plus x equals 7/8. So if we're going to solve this equation, I simply need to, I'm just going to write this a little bit closer so that it's easier to solve. I need to get my variable by itself. Since we added 1/12 to x, I will subtract 1/12 from x. These will cancel out, leaving me with x. Over on the right side of the equation, I have to get a common denominator between 8 and 12. And for some people, this is a bit more complicated. I always tell people, look at your bigger number. Think about it. 8 does not divide into 12. 12 times 2 is 24. 8 does divide into 24, so my common denominator here must be 24. 8 times 3 is 24. 7 times 3 is 21. 12 times 2 is 24. 1 times 2 is 2. So if I subtract 2 24ths from 21 24ths, I will get 19 24ths. And since this is a word problem, we need to write the answer in a complete sentence. So the weight of the fruit, because that's what we were asked to find, if you remember, x is how much does the fruit weigh. We we solved for x, so x here is 19/24, so the fruit weighs 19/24 pounds. All right, let's look at our last problem. You hammer a nail 2 3/8 inches long through a board. The nail pokes 5/8 inch through the other side. How thick is the board? Okay, so if you think about this, let's just draw a little picture for a second. Think about this as being my board. 3, 4, D. I'm going to hammer a nail through it. Let's pretend this is a nail. It goes all the way through the board and it sticks out a little bit to the other end. Okay, which means that if I know how far it's poking out right here, and I know how far the thickness of the board is, that has to equal the length of the nail. Which means the thickness of my board plus the part sticking out has to equal the total length. Now, we're asked to find how thick is the board. So I'm going to let T equal board thickness. Okay. So my board thickness is T plus the part of the nail that sticks out, that is, the nail pokes out 5/8 of an inch, has to equal my total nail length, which is 2 3/8 inches. So I have T plus 5/8 equals 2 3/8. So we need to solve this equation. To solve this equation, I must undo what was done to the variable. They added 5/8, so we need to subtract 5/8. We do it from one side of the equation, we have to do it to the other side of the equation. These will cancel, leaving me with T. I cannot subtract 5/8 from 3/8. We learned that in the last lesson. So I'm going to have to rename 2 3/8. I'm going to rename 2 3/8 as 1 8/8 plus 3/8, which is 1 11/8. And I'm going to subtract from that 5/8. So now I can subtract these. 1 11/8 minus 5/8. Well, 1 minus nothing is 1. 11 minus 5 is 6. So I get 1 6/8. But 1 6/8 will reduce. 6 divided by 2 is 3. 8 divided by 2 is 4. So the thickness of my board is 1 3/4 inches thick. So there you have it. The most important part with writing equations is making sure you write them in the order of which the problem is asking. And this is solving equations with fractions.